Okay, it's about time. Let's get started. How was your first assignment? I saw that many of you got into some installation problems and maybe permission based on the feedback that I got. Mostly, those may occur from the font. Right? Thai font is not part of the standard font in operation, right? You know that, right? In terms of the text encoding and others, so it is possible that when you use a Thai font and it might not be translated well with R and RStudio, and then it causes some types of path problems. That's one thing. And another thing is in terms of the permission, because when you install libraries, you need to permission to copy the file onto that folder. Sometimes on some computer, you may encounter that there are permission problems, and it kind of prohibited the installation of library. So what can you do? You can change the library path. You can assign administrative permission for the software, so that the software can write, and there are many ways to deal with that. So it depends on how you do that, and it only occurs on some computers. On some of them it might not, and it depends on the users type that you have on your computer as well, whether that user types can write, read, and do a thing. So mostly the questions that were asked of me on the past, I say 3 or 4 days were about this, were about installation issues, right? And mostly you got it right, so great. And I suppose that you have become familiar a bit with R and how you can use that to create a workflow of the data. So starting from having the file, the data as table, and then prepare it into the spec, right? It depends on the specification that you have. You can change it to cross-tab style report. You can create an analytic-based table for further analysis. Okay. For today, we are going to look at another package, another aspects of data modeling and visualization, which is the visualization part. Right? We are going to look at the basic types of visualization. Just only this, it would allow you to be able to create reports, understand the role of different types of visualization. I think the key takeaway of this class is not only how to use RStudio, the Ggplot 2 package that I will teach to create visualization, but also the role and the purpose of different visualizations. That if you realize that they are important for each of the information piece that you want to communicate, and then you are able to use them correctly, then this will be beneficial in the long term, because there are actually plenty of software that can be used to create visualizations such as these. Even a basic Microsoft Excel can perform the task, the spreadsheet one. That means, well, you are actually not limited to just using code. You can use the Excel, you can use Google Sheet, you can use the Apple one, I don't remember the name. You can use the Tableau, Power BI, TIBCO, Spotify, ClickWheel to create visualization as well. You can use D3.js to create a web-based visualization, or the Wiz.js to create the interactive visualization. So there are many ways that would allow you to do so. Okay. I will show you some of the website that I talked about. For example, the D3.js, which is an interface that you can integrate it with your website. or the WizJS, which allow you to create an interactive visualization and able to connect to actually some code here as well. And also the Power BI, which I think we will learn that. Oh no, not this course though, but I'll show you some later on, that there are software that you can actually drag and drop and create visualization, and it's actually free for students to use, like Tableau, like Power BI Public. You can use those if I remember correctly though. All right. So let's begin today's topics, right? Today's topics will be a lot more focused than last time. Last time we covered an entire RStudio introduction, which you probably have to get your head around a lot, and you probably need to practice a lot more in order to be able to code with R. But today we are going to just look at one library if we talk about coding term, or we are going to look at one topics, which is a very important topics though, is the topics of data visualization. Okay, we are going to use this throughout the course, right? Not just today. I would say that the remaining of the lectures requires a little bit of use of the data visualization tools. And also I would say that other courses, when you learn that either it will be statistics, economics, your project, you will require to create some types of visualizations that connect with data. Okay, so what we are going to learn today are first Ggplot 2, which is a package in R that allows you to create visualization. And it is nicely packaged, nicely designed package that is separate the part about data manipulation, data visualization, and aesthetics from one another. And the second topic for today's lecture will be about the objective, right? The objective of each of the graph. Right? What type of the visuals should you use on different purpose? For different purpose. Okay, let's begin. So similar to last time, if you have any questions, feel free to ask them right in the class, in the chat below, or maybe afterward. But for the interactive purpose, if you have questions right now, ask now. And because this course will contains a lot of code, but I did not have the file for you this time, because you can practice and type in yourself later on when you do the lab. So in this course you can, if you want to do it together with the video, that's fine, right? But you can also revise and doing this later on. There are already codes in the slides that you can follow through. Okay, what is Ggplot 2? Okay, Ggplot 2 is a package in R, obviously. Right, Ggplot 2 is a package that is designed for data visualization. Right? It is created in a way that it separate the data and it separate the visualization to different parts. Right? It is claimed to be a system for declarative creation of graphics. That means you can create graphics using a declarative sentence, not declarative sentence in terms of English, in terms of R code. What you need to do is to provide data, that's the first one, and tell Ggplot 2 how to map data into the aesthetics, into the visualization. Which part of the data should be mapped to x-axis, which part should be mapped to y, which part should be mapped to color, right, or the size, and what graphic primitive, the types of graph that you want to display to be used, and also details. So this is how you use Ggplot 2, basically like this. First, you need to declare declare the library usage, right? Usually you can just declare the Ggplot 2 using library Ggplot 2 or library tidyverse. And then we are going to use the MPG data, which I will explain briefly later on, to create a plot. And then you need to declare first that, okay, you are creating a Ggplot object with the data, the MPG data, and then this would be assigned to variable p, right? P then will be used further if you add the Geom call. Geom call is the type of graphic that you want to display. It's a function, right? So this Geom call will contain the mapping. This is what to plot. You want the column plot, and then you want to map the aesthetic of X to class and Y to the HWY. So let's take a look at this a bit. This is how you use Ggplot to. Let me switch the share to RStudio. Right. So here we need to load the library. Tidyverse, right? And then run. And here the library is loaded for all the packages that are related to the data manipulation. Next, what I'm going to do is to assign the object, right? Ggplot, data, MPG. Okay, first, after we load this data, let's take a look at the MPG data first. This is the MPG data. Okay, if you want to know what it is, you can type the question mark and then MPG. This is the fuel economy data from 1999 to 2008 for 38 popular models of car. And there are explanations here on different variables. What they are. So we can know that, okay, HWY is highway miles per gallon. Right. So what I'm going to do here is to first, if I were to just not assigning here and create a Ggplot object and then run, and you can see that on the lower right hand side here, the plot area becomes gray. Why is that? Because now I actually create a plot object, and then when I throw this plot object to the standard output, meaning that I did not assign to any variable, it plot the graph. That's why you got this plot. But if I were to assign to variable p and then run, now we got variable p. The p is a type of object that contains the plot. It will contain the data and the necessary elements in that required to plot. Think about it as the Ggplot2 object. Okay, then with this we can then further manipulate them, right? And then create a graph. If we add the Geom call, what is the Geom call? You may wonder. Type F1. This is bar chart. Okay, it will tell you that Geom bar makes the height of the bar proportional to the number of cases. So it's like counting the number of rows. Geom call, if you want the height of bar to represent value, then use Geom call. Okay, we will do that. Geom call. And then in all of the Geom, you need to follow the format. That is, you need to provide a mapping. Why do you need to do that? Because you need to tell Ggplot2 that on which part of the data should be mapped to X, on which part should be mapped to Y, on which part should be mapped to color. Like that's why we need to specify mapping. Okay, mapping. And this mapping we'll need to encapsulate in the aesthetic function. And inside here, mapping, if you look at here, set the aesthetic mapping created by AES or AES underscore. If you specify and here AES equal true, it is combined. Right, so it is created by the AES. The AES is the construct aesthetic mappings. It would help describe how variables in data are mapped to visual properties. Please note on the upper right, upper left corner that this is just functions from Ggplot2. Right? It comes from Ggplot2, not the standard, the base R. That means you need to go to the library here to know that. Okay, let's map it. X equal class of the car, and y equal HWY. Now if we run this, you can now see the visualization down here. This is created from this, right? Because it now map x to class and map y, the y value here, to some value HWY here. Okay. All right. So now we have seen how Ggplot to work. What you need to do is to create Ggplot object and then add something to it. Oh, by the way, you can doing lots of things further. For example, and you see it later on as well. For example, you can assign this to another variable, say P1. And then from P1, you can add P1 to another geom, say Geom. What should I use? Geom Histogram. Mapping AS X equal. I'm just overlaying them together. There's no meaning for now. Okay. Right, but it is. I should use Geom line to. Never mind, it's hard to overlay here together. Because it would be better if this is not the bar graph. Okay. Maybe I can just use author type of scale color, continuous. These are the functions that allow you to modify the graph further. Like you see later that you can specify the color, the gradient color if you use the color text here. But well, at first I thought maybe I can show you now. Maybe let's do it like this first, and then we'll come back to it later on. Okay, so for now you can create the data object. You can create the Ggplot object, and then you can add some types of shape with the Ggplot, and then it will create a graph like the syntax. Okay, so what types of graphs that can be created using Ggplot 2? Okay, there is just like the dplyr and tidr. There are cheat sheet which allow you to see the summary. You can just click the link here or search Google. To use Ggplot 2, you need to specify here the data, the object, Ggplot object, and then you need to specify geom function. And then you can specify further the modification of the graph here. So what are the types of graph that you can plot? You can use these graphic primitive to plot like the path, the blank, the ribbon. You can create some types of, if you have a continuous of values of both x and y, then you create some types of the point plot or scatter plot. You can create a geom smooth, which will create a smooth transition. Sometimes for this is method LM, it will create a regression line between the two data. You can create the bar chart that we create here, the Geom call and box plot and others, which we will look at today on different part. Okay, so that means you can use the cheat sheet to look at the types of summary on the types of summary of the graph that you can plot. Okay, what are the advantages of using Ggplot 2? Okay, comparing to why not just look at the data. Okay, Ggplot 2 allow you to create graph with consistent graphics primitives. That means there are like basic functions that can be used to create graph, and they are quite consistent throughout the package. Okay, it means that you need to declare data, you need to declare the plot, you need to declare the modification, just that. Okay, and the specification is very high level of abstract. That means instead of delving into if you ever write C to plot the graph, that's a little bit complicated because you need to go into low level. But here these are high level. You just need to specify column you want to plot, the graph you want to see, and then it show it as that. And I think that here the way that you create graph using Ggplot is actually a lot easier than when you use Excel, for example, because you can create a flexible graph, can add lots of things on top, you can manipulate data at the same time of creating graph. You can create theme, you can and you can add on many author. There are many author packages that are compatible with Ggplot 2 that can be combined. But Ggplot 2s may not be suitable for these purposes. Suppose that you want to create the three-dimensional graphic, then there's the RGR package, not this one, right? Ggplot 2 is for displaying data in 2 dimensions. That's usually the case. You can, if you want interactive graphic, then you should use the ggwis package, or opt to use the web, right? The web based package, which I think I could show you here. ggwis, wisjs. WisJS for dynamic network. Let's look at D3 JS. If you want an interactive plot on the web, Ggplot 2 is not for that. You may use this one instead, I think. Let me expand it. Here. This is D3JS. Is a JavaScript library that allow you to create visualization. For example, you can create a visualization like which one should we select? Say this one. Here, these are the code in JavaScript, and it create these are the code in JavaScript, and it create this tree. And this tree, I think you can manipulate it a bit using. This is just display. Let's look at some interactive visualization. Phylogenetic tree. Here. This is the phylogenetic tree, meaning the scientists compare the similarity between organisms created from the paper in Nature. And you can see that there are like interactive way that to display it by showing the kind of emphasis on where your mouse over, and then trace the part so that you know that this is part of the of which family, of which branch. Okay, so if you want interactive, then that is one way. There are also other which you can use, and you can apply to use them freely. Software like Tableau. Like this one, Tableau. Tableau allow you to create the there should be some types of this one, Code-19 Data Hub. Yeah, it allows you to create a dashboard like this, and then you can interactively playing with this like this. COVID Data Center. This is on ArcGIS. Right, so when you see the dashboard like this, these are usually created based on from the software, from this type of software. You can ask for the free license. I think there are free license for students to use yearly, and it can be renewed. I got one for teacher here. You can use this to create visualization similarly to Jitter Plot 2, but with drag and drop. The actual cost of license is a little bit pricey though for student. Okay, so that means for Ggplot 2 you can create visualization using R. The basic idea of Ggplot 2 or the grammar of graphics is that you can specify the building blocks of the graphics and then combine them to create different types of graph. Okay, what are the building blocks that are need to be specified? First, you need to specify data. And then you need to specify the mapping, which part of the data should be X, Y, color, density, size, and then the geometric object that you want to see. So these three are essential for the plot. And then you can also specify other elements like the scale. What does it mean by scale? It means that how would you scale x-axis? How would you describe the scale of the color? Should it be discrete? Should it be continuous? Should it use some types of gradient mapping, or should it be like static color? This would be scale coordinate system in case that if you are plotting in polar coordinate or rectangular coordinate, or you want to change coordinate to further of offsetting. That means you are dividing the graph into multiple facets, into multiple panels. All right. The concept of grammar graphic is based on the book by Professor Wilkinson. Right? This is the foundation of a lot of visualization software that we see now in the market. Right? This book explains the concepts of visualization, how to make graphics. That's a lot more easier to understand. So let's jump to the code. Okay, what we are going to use here is the full economy data here. It contains the manufacturer as character. That means this is types of the manufacturer of the car model, displacement, years of manufacturing, cylinder, and the transmission, the drive, whether this is the like four wheel or forward drive. City, I think this is the mileage per gallon in city, mileage per gallon in highway. I don't remember. You can look at this. Okay, I got this explanation. Fuel type, diesel, I think, or not, and the class, which is the type of car, minivan, sedan, and others. Okay, how do you know how? There is actually a nice function in R that allow you to see the distribution of the data, whether you have like the numerical data or whether you have the data as category. And that is because R has factor, and with factor and with this function, it would show you the distribution of different variables. What I'm talking about is the function called summary. The summary function can be used to show the distribution of the data, right? For this one, you can see that I use from MPG. I put it into mutate here. Mutate if it means that for each column, it will mutate the column. If mutate will create a new column. If is character, this is a function to test the column. If that column is character column, then this function will be applied as factor. And then I got this MPG1. Okay, let's take a look at this first to see the different. All right, here if I use MPG directly, summary MPG, what you see would be this. You see that a lot of why is this the case? You can try load the MPG, right? Data MPG, and then see how that is the case first. Here you can see that there are 11 variables, and these are character, not factor though, character, integer and num. Okay, when you use summary with this, it will show you that these columns are character class. These are character class. For numeric 1, it will show you the distribution, the min, max, the median and mean, and the first and the third quartile. Okay, so you know roughly now for numerical variable, at least, that these are the distribution. But you can see that for those character columns, the columns are not well summarized. If you want them, to be summarized in terms of the count, in terms of the number of instances that occur, because usually when we look at distribution for numerical variable, we look at the numerical distribution. When we look at the distribution of the categorical of the text variable, we usually look at how often it occurs, right? And then we know some types of prior distribution, which one dominate which. Okay, so what do we need to do in order to know those distribution? Right, we need to change. There is the function called mutate if. This function, scope verbs if at all have been superseded by the use of a cross. Okay, so there are some change in the way that you can write this. Usually I use this mutate if, but there is like the new way which you can look at this later on how to use it. Mutate across. Yeah, mutate and then across. Okay, so it used inside instead. All right. So the old way would be like this: is character, and then convert this to factor as factor. Which, if you run it, you see that okay, as factor. Oh, it's supposed to not giving. It should be just the name, right? And then now it would be converted to the factor here. It's already A4. Okay, it's character as factor. This is the old way. New way would be mutate and if, I think. Mutate across. Let me try this. Nah, I should. Yeah, it worked, but there are some. Select where. Yeah, I should look at it. Never mind. We can look at it later. It's like a new way to write this, but let's stick with the old one. So this is the mutate if, and then we can assign this to the variable mpg1. Now we have the mpg1. When you look at the structure of mpg1, you can see that now you have the factor, which means that when you use the summary function, it will now count factors into the number of occurrence, which allow you to be able to determine the distribution. For example, you know that okay, you have about 103 four-wheel drive, and forward drive is 106, and rear drive is 25 here, and then it means that we can see the distribution by using summary. This is quite a powerful function because you can see the distribution at a glance. And when you work on data science project further and further, you see that this is very important thing to be able to evaluate the distribution at one go of all variables. Okay, now we are going to take a look at how we can create Ggplot in the full form. All right. So this will be a little bit complicated. That I want to an example that I want to introduce to you first, so that you can see different part of this, and then we work together to understand this. You can see that the plot down below is a types of scatter plot together with some type of line. Okay, and you also have this separation into facet, into panels in for this one in the horizontal axis, right, into multiple panels based on this value, right, 4, 5, 6, 8 cylinder value. So how can you create this? It is created by the code up here. Let's try to do it line by line, okay, and then see what is the result, and then we will see like how this is developed. So I'm going to switch to RStudio and then work on the code. You can look at the progress here. So start with the Ggplot, right? We need to first create a Ggplot. Ggplot data equal mpg. If we run this code, we will have an empty graph. Okay, this empty graph, if we add the thing that we want to plot, which is geom point, and mapping that we want to map the aesthetic x to cty and y to hwy, and then plot. Now we have a scatter plot. Right? We have the scatter plot that the x-axis is cty, the y-axis is hwy, according to our specification here. And we can further assign the color to class. You may now wonder, what types of keyword should you use in order to work with this geom point? You can look at the help from geom point F1 here. This is geom point function. And when you scroll down here, you should read through the help here. It will tell you that the aesthetics that are available for geom point comprise first x, second y, and these are in bold, means that they are required for plotting this graph. If I not specifying this and run, then it will tells me that it's not possible to create that plot. Okay, so I need both x and y, and you can modify it further, because there are like alpha, color, fill, group, shape, size, stroke, right? These are aesthetic that can be modified. For example, if I assign alpha, which is like the transparency, right? You can see that they have like different transparency. Alpha should not be discrete because actually it should be the value between 0 and 1, right? The alpha value. This is class is discrete value. So color here, and the color in LOR is similar, right? Because I suppose the team work on both British English and American English for that. All right, so now we have this nice graph that show you a scatter plot. Also label the color into the graph. Okay, and we can, okay, we have this first graph, we can assign it to P1. Now we will have P1 as the variable. If I clear this and then I just type P1 and then run, you will have the graph, right? Because you are throwing the P1, which is Ggplot object, to standard output. It will plot the graph for you. You can add also as well P1, add with the Geom smooth. Geom smooth, we create a regression line. Actually, we create the smooth line based on the data that we give it to the system. Let's look at the help. Geom smooth is smooth conditional means. Okay, so that means we create a types of smooth line based on the data that we specify, and those data comes from the aesthetics x and y. It creates a types of interpolated lines that display on the graph. So if I use Geom smooth like this, right, it said that okay, using the method lowest formula y tilt x, right, error smooth require following missing aesthetic x and y, because I did not specify the aesthetics. Why is that? We did specify those in Geom point, right? Now you need to think about this as an object, right? Like in an object-oriented programming. In this case, we specify aesthetic mapping for Geom point, but we did not specify aesthetic mapping for Geom smooth. So it does not have that information. If you want that information to be shared across the multiple plot, then the aesthetic should be specified here as well. Mapping aesthetic of x equals cty and y equals hwy. And then we can try to plot it again. Now you can see that there's a line here. Okay, and for this we can remove this aesthetics x. Right, we can remove it out because now we have specified the aesthetic from the Ggplot object. Right, that means different geometric object will now know that x should be mapped to cty, y should be mapped to hwy, and then from Geom point you just add color in. For Geom smooth, well, you already know that, right? So that's why. So the code will be a little bit different from the slide. And you can also specify the method. The method here is lowest interpolation. Right? We can specify the different method. Use the linear regression model. And now we have straight line passing through the data. Okay, we can further modify this by adding the scale color, and then use Brewer, fine, and then use the type equal qual. Now you can see that the color of the dot or the color change because we now specify that if there are any color aesthetics in the plot, those color aesthetics should be mapped to the Brewer. Brewer is a type of palette that has the Brewer scale for color that has this type qual. But there are actually other types as well, and there are like different types of specification for the color for the other thing as well, which you can look at the scale. And there are multiple ways to specify the scale. These are scale color, scale fill, scale line type, scale shape, scale shape, scale shape, scale x, scale y, and others. Okay. For now, we now have this object, right? This beautiful interpolation and scatter plot. I'm going to assign this to P2. Done. Okay, now if I clear this and then say type in the console, type P1, then I will get the P1 plot. Okay, if I type it P2, I will get the one that already add that, and go back again P1. You can see that there are like a different version of the graph depending on the object that got plotted. Right, now I'm going to add from P2, add another element, add the facet by adding the facet grid. This facet grid can be used to divide the graph according to some variable. Okay, dot tilt CYL, right? Dot mean not specifying. For this, tilt means that it is used to separate it y and x. So it means that we are going to use CYL on the x-axis and nothing on the y-axis. Run, and I got this separation. Okay, if I were to switch side, CYL and tilt and dot and then run, then I'm going to end up with this. Okay, and you can imagine to use author as well. Let's use manufacturer, but it won't be beautiful. Data points are too sparse. Manufacturer. Right, there are too many of them to plot here. Yeah, or DRV. Yeah, now you can see that they are like divided into panels, right, according to the data points that they belong to. So facet grid would divide the data into grid based on the format that you specify here. All right. Now let's take a look at each element in this example. Okay, so you can see that first you need to specify the Ggplot object and the data that you want to use, and then from this you can add the aesthetic mapping and the geometry. The geometry here is the point geometry, and then this point geometry would plot the mapping of aesthetic of x, cty, y, y, and color equal class. And for P1, add with the smooth line geometry here, and the color scale, change it to qualitative type. And lastly, partition the plot with CYL. Okay. Is it easy to use? You can see that just specifying different objects independently, you can create a plot that reflect the values of the graph. Right. So now we see that you need to specify data. You need to specify the mapping. Okay. What types of mappings are available? Okay. If you look at the help, you can see that the thing that you can specify would be something that you can see. That's why it's called the aesthetics. It would be something that you can see. You can map variable to position, color, fill, shape, line, size. Okay. Each type of geom here that we use would accept different aesthetics. You need to check them first on what types of aesthetic that are mapped. And you can check it by just type geom and look at the help. Like let's look at point and box plot and others to at least see what types of aesthetic that you can use. Geom, let's look at geom bar, geom call that we look at first. For geom call and geom bar, the mapping that are needed are x and y. Okay, you need to specify x and y. And once you read through this, it will tell you that x, what types of graph that it will plot. Geom call as well. You specify x and y. Let's look at another function. Let's say geom line graph. Connect observation. Then you need to specify x and y as well. How about the others that are not x and y? Geom say bin 2D. In Geom bin 2D, okay, you need to specify x and y, and then it will calculate the bin. Geom box plot. Geom box plot. Again, this will be the way that box plot is created. Right, you need to specify x and y, x or y. It would create a box plot for you. You can specify both, and there are the variables that will be computed based on here, down here, and these are some examples of the plot. So it means that different types of geometric object will require different type of aesthetic. There's no upper limit. You can specify a number of aesthetic into geometrics. And you can add geom to one another on top. So now we see that for Ggplot, you need to have data, mapping, and geometry for the plot to work. Okay, let's take a look at different geometry and the types of graph that it will create. Okay, I'm not going to type in now because there are like a number of them, but I'm going to explain it based on the code that I use and the graph that I got. You can practice testing it, and then create different plot later on by yourself. You can create a bar chart, right? What use of bar chart? Usually we use bar chart to compare the values of different categories. Like we have different category here, we can compare the values that differ between them, right? The Geom bar would create a count bar chart. Okay, this is a count bar chart. What does it mean? It means that it would, because I specify only x, that x equal class, what Ggplot2 will do would be, it would use the stat count. It would count the number of occurrence of different elements, different class, and then you got this count in bar graph. You can plot the bar chart, but instead of the count, the number of row, you can plot it in terms of values. But note that to use this Geom call, to use Geom call, you should have the value like one class, one value. Otherwise, there will be a problem. We will see that in some example that I'll show you. So what I do here is that from the MPG, I group MPG by class and then summarize to be average HWY, to be mean HWY, and then throw it to the Ggplot2. Ggplot2 then add the Geom call, which will plot the average HWY in Y and then X in class. So let's take a look at the code for a bit. For this one, if I use the Ggplot and then data equal MPG, and then add with the Geom bar with aesthetic mapping aesthetic x equal class and run. What happened? Mapping Geom bar should be fine. What did I miss? Okay. Right, now we have the count, right? Count plot. If I change this to Geom call and then say I want it to plot the HWY, if I use it like this, right? It will plot the graph for you here, but you can see that the value is strange because if you look at the summary of MPG1, you can see that HWY, the mileage per gallon, should be about 10 to 40 something, not 1,000. Right? Because why is this the case? Because if you did not specify any type of summarization, right? Because now we have like multiple rows, and because Ggplot2 has to figure out a way to summarize the value by itself, is calculate the sum. It calculates the sum of the value, which create this graph, which is wrong. Okay, so there are two things that can be fixed here. You can specify the stat to be some type of stat mean, using mean instead, or you can summarize the data first so that you have like one value per one row. Okay, because now for now if you look at the MPG, right, you can see that there are multiple compacts here. So how do we get just one? What I can do is to use the MPG and then pipe and then group by class and then pipe and then summarize and then use the AVG underscore HWY equal mean of HWY and test it. Now I have one line here. You can see that this is one line per class, and each one has the value of AVG HWY. So then I can replace the MPG with this, which I can do it by this, like MPG2. Assign it to MPG2 and then replace this with MPG2 and then run. Oh, don't know HWY, right? So y equal avg HWY. Now I have the average mileage per gallon for each class of car, and you can see that pickup has the lowest rate, and the compact and compact and subcompact have highest rate in terms of fuel economies. Okay, so this is the Geom core and Geom bar. Right, okay, I'm going to move along. The next one would be the Geom Histogram. Okay, Geom Histogram will show you the bar chart as well, but this will be the bar chart of the histogram. Have you learned the histogram from the stat class yet? Have you heard of the word histogram before this? The probability distribution. This will be the data distribution or frequency table. I think you may have learned that in your high school as well, right? To bin the data into range and then plot it as graph. We call that a histogram. You have encountered this before, right? The histogram. Some response, please. Yeah, I'm waiting for your response. Have you seen or used the histogram before? Histogram, yeah, right. You have data, then you bin the data into range, and then you count the number of occurrence and plot them. Yeah, for one of the high school project, and you learn it again instead. It's very important, right? It's very important graph for data analysis because it shows you the cluster of data. Okay, for this one, you can plot it by specifying the aesthetic x to HWY, and then it will plot this graph, the distribution for you. Actually, you can even specify it further. You see later on that fill should be, say, white, and the outline should be some color. It will look a bit more beautiful. Later on, you will see. Okay, so this is histogram. Just use Geom histogram. But if you want it to be normalized to 1, that the area under the curve should be 1, then there is a function called Geom Density, which will plot the density function for you. Looks like histogram, but more of the average or the contour part, or the I would say the envelope part of the histogram. Okay. It's Geom Density, and then there's this Geom area, which you can plot the area plot here. And if you use the stat bin, it will plot the histogram as well for you. So I'm just showing you the different types, different plot of histogram using different function. You can use the Geom histogram, standard one, Geom area, which also show you the count, right? Because we use stat bin to modify. If not, then it will show different graph. Stat bin would bin the data into bin, and then for each bin it will show values, and then you kind of plot it on the top. There's this Geom dot plot, which will show you the dot plot, giving it dot plot is for this one is also the stat bin, which means that it would bin the range and then plot the graph for you. Plot the graph for you so that you know that this is the number of occurrence. The highest one would be in 1, and then the rest would be comparing to the highest. Right, this is the Geom dot plot with color. Do it with color, and so Geom dot plot with fill, right? Fill now become class. So instead of having this black dot, now you have the class filling in the dot. So in order to fill mean the color inside the dot. Okay, if you have circle, fill is the color inside, and the outline will be color. And the dot size now changed to 0.7. Okay, another one, this is Geom Box Plot. Geom Box Plot will show you the box plot. What is the box plot? We will look at that in the distribution lecture next time. Okay, the box plot show you distribution. I show you the 50% of the data in the middle. Right? We'll look at that in the distribution next time. You can create box plot by specifying that X should be mapped to class and Y should be mapped to some value, which is HWY. And color here, I use class to fill in so that you have different column with different color. This is the box plot. You can create a violin plot. A violin plot is a plot just like box plot. But instead of viewing just 50% in the middle, we plot something like a density. Right? Density on top of the box plot. So it's something like box plot with the histogram or with the density as the outline, as a shape. So you know that, okay, for this one, you got the right skew, right? Some types of a long tail on the high value. For this one, you got something like a leftward skew for minivan. That means most of the data are clustered in the end, in the high value here, just like two-seater. For compact, mostly they are clustered down here, although the maximum value is quite high. So with this, you know a rough estimation of the density of the data. Okay, this is violin plot. This box plot plus density. Okay, you can use violin and then map X to class and Y to HWY. Now let's move along to those are one dimension. Okay, for two dimension, right? What you need to do is to specify both X and Y. Now you have two dimension, right? Using Geom point, this will plot the graph that X is mapped to one and Y is mapped to another. Each point here is an order pair. Okay, each point here is an order pair in your data. That means one point per one line. Okay, one point per one row of the data, and it plot into the graph. But there might be a problem that Geom point might kind of colliding with another point. It kind of overlay on top of another point. There is another plot called Jitter Plot. Jitter Plot is like the Geom point, but it adds some jitter. Jitter means it adds some type of random adjustment, right? And random adjustment on X and Y. You can specify the degree of adjustment so that you have the data. If they are the data would not be plotted according to the values, it will be shifted a bit according to those random values, so that you can see the types of clusters if they are like one point that are repeating on top of another. Now, okay. Now you see that with different geometry, you can create different graph. Okay. Now, in order to modify it further, you have seen this already that, okay, you can specify the parameter inside, like the dot size equal 0.7 here. But you can also adjust it further by using using scales. Scales can be used to map the display of aesthetics, like map the shape into other variables, okay, or map the color to other variable. Okay, why don't we use it directly? Let me try this and then show you. All right. Okay. For example, for this one, if I use color equal class and then run, then you can see that now the outline becomes color. If I use fill equal class, then here inside it would be filled with color of the class, okay, based on the palette. If I specify it to red, for example, it becomes red. But the weird thing is that now here you got fill red, because you now kind of specify that red should be data and that it plot it as red, which is wrong actually. How about we move fill outside the mapping? Now you got red color. Okay, that means actually aesthetic can be specified, can be used outside of the aesthetic function, but it would be just a constant value. Okay, I can change it to red to blue, and then I got the whole thing as one color, or I can use the code as well. However, this is just a static value. What if you want the values to be changed according to your rules? That would not be you wouldn't be able to do it by using just this geom function. Okay, we got geometric mapping already, that you can map variable with x, y color fill. When you use something like using aesthetic function and specify color to just one value, it doesn't say what types of color should be used. You can see that if we were to specify it like red, blue, then we can specify the value. But if for example, this is here, like this, then let's say that I don't want these color types. I want it to change. Like the first one should be blue, green, whatever that you want it to change according to your preference. Then you need to use scale to modify color, shape, size mapping in terms of values here. Scales can be used to modify color, position, size, shape, and others. Usually we start with scale and then score and type aesthetic that you want to modify, and then the types. Okay. You can modify it like in the scale. You can modify the name, label, limit. You can modify the title. You can modify the label of data. You can modify the color. Okay. Let's see how it works together with certain function here. Okay, this is a little bit more complicated function. It's called bin2d. Bin2d is a histogram in 2 dimensions. So what does it mean? It means that both CTY and DISPL were binded, right? Were binded 10 by 10. And we map X to displacement, Y to CTY. Okay, we got this graph. And without scale, how does it look like? Let me try typing it for you here. Ggplot. MPG. You can see that you can opt out not to specifying. You can choose to not specifying the data equal parameter specification. Just use the name, then it is okay as well. Geom bin2d, and then what you need to do is to specify the mapping. But this is a lazy way, a better way to specify all of them, because it will help you when you read it and so make a thing less confusing. X equal DSPL and Y equal CTY. Right. This is the value that the graph that you see. If we specify it to 10, okay, say that bins should equal just 10. Then you got this one, just 10 bin. But the color is black to blue, some blue here. But I don't want that. What I want is to red. Then what you need to do is to well, you can write it in multiple lines. Just add plus here. And add the scale. The scale underscore fill. And then there are multiple values that you can use. I'm going to use gradient. If I do this, then if you use standard value, which is this one, I'm going to change it from low, say in the sheet I use 0, right? Let's change it to FF, the white one, and then high to the red one. What should I do? Red, green, blue, FF0000. Then run. Okay, now you got a 2-dimensional histogram, 2-dimensional density plot that the low value should be white, high value should be low value be white, high value be red, which doesn't make good sense in visualization, right? Let's switch a bit. Change this to black 0 0 0 0 0 0. For the high, let's change it to white. So now we got the black and white plot. Okay, by modifying the scale fill, right? You can modify the color that is filled into this, right? And this is the Geom 2D, Geom Bin 2D. There are other similar plots like Geom Contour. You plot something similar to Geom Bin 2D, but as a line in a contour plot. Contour plot would plot the high peak as center line, and then it will just going down here. Okay, you can plot and aggregated values by summarize them first, like using this group by, and then summarize. I got CTY, HWY and the summary version, the mean version, and then put it into Ggplot, and then plot a point, and then add the Geom text. Geom text would put in the label, okay, and you can use the variable to say that, okay, this is the label and not y, meaning that it will shift in y direction by minus 0.3 point, right? It will shift down a bit, and then specify that x lim, the limit of x value should be 15 to 30, right? And then I got this plot. Right. Okay, so those are first example that you can see that first example in terms of data that there are, like you can see multiple types of plot that can be created in terms of comparison in 1 dimension and 2 dimension. Now let's move on to the next one. The next one will be I'm going to use the economics data to discuss about this. Economics data show the date of data collection in 1967, PCE, population, self-RT, unemployment, UM, MET, and unemployed. Let's look at the explanation. I don't remember as well. Let's look at the explanation in the help. This is the economic data. I should use this economics. F1. US economic time series data. This is from Ggplot object as well. Yes, economic and economic long. There are 6 variables. First one is months of data collection. Second one is personal consumption expenditure, PCE. Okay, personal consumption expenditure in billion of dollar, and population in thousand. Personal saving rate. The saving rate. I think that's supposed to be the interest rate. And UMMET is median duration of unemployment in week, and unemployed, number of unemployment in thousand. Medium duration means that how many weeks that are mostly unemployed. Right? Unemployed people are mostly unemployed. Okay. Now let's look at the time series. The types of data that are time series data would contain the time in one column and the values that you want to plot. For example, you can plot this economic data using a line plot. A line plot by map date to X and then Y to unemployed. Now we got this unemployment statistics over years. Okay, and you can see that it's got higher, but that might be because of the number of population. Okay, increase as well from 1970 to 2000. I think this is supposed to be 2019 something. I don't remember though. I should look at the maximum value. I should look at that. The maximum value of that. Let's use summary. Economic. The highest value is 2015. Right, on April of 2015. So this is April of 2015. Okay, so now we are going to look at time series plot. We have this Geom line plot as a line. A line plot would connect the dot. So it is like the dot, the scatter plot, the scatter, but instead of using geom point, we use geom line so that each dot will be connected to one another. And then you can plot the geom ribbon. In geom ribbon, you can specify y min and y max, and then it will plot in area, in ribbon. Okay, so instead of plotting as one value, we can plot it as interval. Right, this will be an interval of y minimum and y minimum and y maximum. You can plot a step plot. A step plot would be changing in step. You can see as changing as step. I just use geom step, and then for xlim, I just specify that I should plot from first to last. This is the modification of, this is the plot that are related to time series. There are also, which you can play later on. The lab today would be, I will ask you to plot whatever plot you want and explain the plot. What does it show? Okay. The coordinate flip is the coordinate, just like the scale, right? Coordinate types would work in modification of the graph. This would modify the coordinate of the plot. Flip would change x and y. So if you use geom bar and then you use coordinate flip, it will change the plot from x-axis to y-axis like this. Right, this is coordinate. So now it will be like auto modification to the graph. A position dot, and position stack. Position dot would create what is called a side-by-side chart. So this, if I use position dot, it would show the graph because I say that fill equal drv here, right? And when I use position dot, the fill value here would be splitted. So you have one color per one color per bar, and they are on the same base level. You might have seen this type of graph in author report. Let's try that. Ggplot mpg, and then you can add the geom that you want to look at, geom bar, and aesthetic that I want to plot, x equal class, and y, not y, because it's geom bar, fill equal drv, and I'm going to set color equal black, so that if not specified, you can see that the graph looks like this. This is called a stack bar chart. A stack bar chart would stack, like you are plotting the number of instances, right? But instead of just plotting that, you now have the fill equal drive. Fill equal drive means that it would divide the data based on the fill. Right? You have like forward view, rear view, forward view, forward driving, and rear driving, not rear driving, and then it is separated into a box here. And by not specifying anything, you are creating stack bar chart. We show you, okay, this is an entire value for compact, but this proportion would be forward, and this would be forward, right? So that means that compact doesn't contain any rear drive, right? But two-seater contain the rear drive. Okay, but if you want to compare, you want to compare that which one is higher than which, stack bar chart might not be good. You might want to separate them, right, by specify the position equal dot, and you see that here it comes down here. Okay, and you got the two here, and this one contain only one class, so kind of bigger. You can modify that later on. All right, this is the position dot and stack. Position fill would create a type of 100% bar chart. This type of plot is useful because it tells you that from 100%, compact contains about 75% as forward and 25% as forward view. Why, if you look at SUV give you like 20% rear and about 80% forward view. Okay, So you now see different types of position. Position dodge, it would just create a side-by-side plot. Position stack would just stack all the way through. Position fill is the stack, but scale to 100%, allow you to compare the proportion, which is again important when you look at the probability, the prior probability or the association between variables, which we will look at in the next 2 lectures. Lastly, there are further modification of the plot in how it is the theme, right? The theme, how it is displayed. That may be the dark theme. You can take a look, or you can create yourself. So this is theme minimal. Okay, you can see that it removes the gray area and whatever, and the types of specifications, and create like a minimal plot here. The legend, right? Legend, if you want to add legend in, you can use scale fill discrete, and then change the title to drive mode. Now you have drive mode discrete, and then labels from 4-wheel front and rear, from 4F and R to 4WD front and rear, like this. And you can further add label on the top here by using X label and Y label. Okay, X label now become car type from something like class, become car type. Y label becomes number of car model from count, number of car models. And the GG title will add in the title and the subtitle, and then you can create this nice graph out here. Okay, right, so you can see that from Ggplot 2, you can create a very nice visualization that allow you to show the data and tell your story. For example, for this one, you can tell a story about the number of models of car that is used in this study and the proportion of that in terms of the driving, in terms of the drive mode of the car. And it will show different types, might have some drive mode, but different types doesn't have one, right? And it allows you to tell stories, which will lead me to the lab, the homework lab. That would be very fun for this. Okay, for this homework, for this lab, what you need to do is to download the data from this link, right? From fast data NTH and data model 2011, there is this data, Superstore CSV. Download this data and then import it to R, create 3 graphs, right? Whatever graph you like, right? Create 3 graphs that will tell stories about the data here. This data is the Superstore data. Let me explain the data to you a bit here. Okay, so what you need to do is to explain the meaning of your graph, and then the question that need to be asked in order to use this graph to answer that. Okay, let me explain the data that we use a bit here, right? This is the Superstore data. Well, you can see that it is a CSV, but instead of using comma, it used pipe to separate the field. So you need to import this into your data, specifying the separation as pipe here. For me, I'm going to just explain it. So I will use this pipe. Oops, I should use the whole way through here. Delimit pipe. Okay. So what do we have here? We have the row ID, okay, and this is like just a dummy running number, and the order ID, which contains the order ID of this is the data from online store, right? The online store, when you order something like in Shopee, in Lazada, you create an order ID. In your order, it may contain multiple items. So you can see that here, you got different line for one order, okay? In this order, this is the order date, the ship date, the date that it is shipped, and the ship mode, and the number of customers, segment of customer, and postcode. And here, product ID. You can see that there are 2 different products that are shipped. Both are furniture. One is bookcases, another is chairs, and product names, the sale amount, the quantity, and the discount rate and the profit. Okay, what you need to do is to import this data onto your R. Check first whether there are problems with the data or not. Like there might be NA, there might be missing. You need to remove them out first, and then if not, then they are fine, right? And then answer the question that I posed here. Okay. Okay. Let me switch to this again. And then you need to create a graph, right? 3 of them for each question that you need to ask. Okay, so this is the profit for each items, discount rate for each item, quantity, that is order in this order, quantity of this order, number of item for this order, for this particular product, and the sales amount. Okay, and this is subcategory, category, and the state, city, countries, segment, and customer ID, and that's all, right? So that is the data description. The data is from online store, right? And you need to in this lab you need to create 3 graphs from those data. Any types of graph would do. Okay, I want the thing that I want you to do is to not just plotting the graph, but to tell story. That's why I asked you the meaning of the graph, and also the question that is required to get that graph. Okay, you create that graph to answer this question, right? So this would be your task for this lecture. Okay, now do you have any questions regarding Ggplot 2 and regarding the data that you need to use in your lab? It's time for the questions. Any? Or again, if you have any questions, or particularly the technical one, after this class, I would suggest that you post it into the group instead of messaging me directly. Why is that? Because your friends can help answering that as well, not just me, and that would create a communities. At first I thought maybe I should open some Discord servers or something, but we have the Facebook group. We can use that, right? Instead of just disseminating the lectures and video and others. If you have questions technically, because I can say that in the past 4 days, the question that you asked me, right? Many of you asked me. They are the same questions. They are the same questions. And I think that 5 of you asked me the same question. That is, if you were to post it into the groups and I answer that into the group, you can just look at the group and then see, oh, that's the case, and then you can solve it by yourself. Okay, so post the question to the groups if you have any, and then I will check the Facebook and then answer that in the group, so that we can have some type of like knowledge accumulation of our class here. All right, so that's it. Try it and tell me how it works. And we are going to use this Ggplot to further in the next subsequent lectures. Okay, that's it for today. If you don't have any questions, let's call it a day for today, and work on this lab and then submit it to LAB2 similarly as PDF right before next time. Right, so for today, goodbye then. See you again next time.